So hello, in this video we will learn about something called continuous random variable and that after that yeah, the types of continuous random variable. Here we will learn two types of continuous random variable, and that is uniform random variable and the exponential random variable. And next we will learn about the cumulative distribution function, that is the CDF. And next will be our properties of CDF. So this video can be suppose that of 1 to 1.5 hour long. So we will complete everything in this video. So sit in a comfortable place where there will be no disturbance. So let's continue. Okay. Okay. Here the first thing is that is continuous random variable. If you think of this one. So suppose you have car and you're telling that and the car is moving at 80 kilometers per hour speed. So is it possible that this is true for every situation? 80 kilometers per hour speed. Huh? Is this true? Is there no humps in that road, or is there no beggar in that road, or is there no turning in that road, or is there no situation that there will be less petrol, uh, and there will be situation. There are many situations you can think of that. There are variety of situations that are dependent on the speed of the car. If you think of in the real life case, if you place a speedometer, uh, speedometer is there on the car. If you place a monitor aside that monitor to monitor the speed of the car, you can see that after you will take up the graph from that monitor, there will be some fluctuations with the speed of the car. If this is the 80 kilometer per hour breeze, then the car speed must be like this. Is this can goes up to 70. Sorry, this can be 81.111, or this can be goes a very less minute 0.000001, or this can be less like 79 point some values 0 291999996. Okay, or it can be 79. So if you say that the speed of the car is maintained at 80 kilometer per hour, it must not be true. Okay, so you need to say that the car is moving at a speed of in between 79 to 81 kilometers per hour. So it must, uh, and this thing will be more correct than this one. So you must say this. So in the context, you have learned that where to use the situation. I have understood the situation where to use this. And if you remember, there are some things like uh, in the continuous, you can think of like that. Okay, uh, like in that in the previous, we have learned that about the what discrete, and you know when to use discrete. Discrete is used in case of when your numbers are finite and um, countably countably infinite. I'm giving one example. You need to write another example in the comment box. So, if you think of the finite case, there will be an example of experiment of rolling a die. It has outcome 1, 2, 3, 4, 5. And if you think of the example of uncountable infinite, you can think of the whole number set. It starts from 0, 1, 2, 3, 4 and goes up to infinity. But these numbers are countable. But in case of continuous, the numbers are uncountably countably infinite. Uncountably infinite. Like someone says you to write all the numbers between 2 and 3. Can you think of this situation? This is so much horrible situation you can get. The number can be 2.5, you are thinking. But if you move more deeper and check off in between a number in between 2 and 2.5, there will be a number 2.22225. You can think of a number between 2 and 2. There will be a number 2222222. It can go up to this one. You can again deep goes deep. It will move like this. Never ending situation. Okay, this is a continuous. You can think of it. Have you now learned when to use a continuous random variable? Continuous random variable is used in case of uncountably infinite situation when you have a lot of number to calculate. So in that situation, think of that situation 2 to 3 continuous random variable solves the problem like it integrates the number from 2 to 3, all the numbers. Check here, all the numbers from 2 to 3 are coming in the integration, and integration is the sum, a symbol of the sum from 2 to 3. So if we put a function in that and integrate all the things coming in between 2 and 3 for that function, we will get the probability for that value, probability for that value uh, in between 2 and 3. This is the context of reading this. So let's deep dive into the definition. So continuous random variable x is called continuous if there is a non-negative function. So uh, uh, first read that sentence. I will make you understand more about the sentence. So when we will learn about this in the graphical context. Okay. So graphical will make you understand why this function must be non-negative, and there is this is a property that is also there, that the PDF must be non-negative. Then we will see what is a PDF. Okay, we're going to that one. So, uh, in this, if I change the color, like so here, if you think of the probability of um, x, uh, if x is an element of the set B, then integration, then the probability of that element will be integration of that point from that area with respect to there will be a function. For that function, the area of that will be the probability. So if you didn't able to understand anything, please stay calm. We will understand this one with an example. So I'm giving that example now. See here, you will be more clear. Suppose think of a sample space. This one is the sample space, and this is your event. And if we were taking the event in terms of the probability, if this one is the PDF, and we will present PDF in the form like this F, uh, like this. Okay. This will be your capital X, and this will be your small x, and this is your F, small f. Okay, small f you must remember because it will be capital F. That will be the CDF. So if you are doing here the PDF, if you was making a graph with respect to x and your in your y axis you have f of x, then you are mm, doing a graph. Suppose this is the function. Okay, this is the function. So you need to know the values in between a to b. So you just need to do the thing that you need to know the area in between. So you will integrate a to b, then with respect to f of x for that point with respect to dx, then you will get the area under that curve. You must be learning this one in your class 12, area under the curve. That is the application of integration. Okay, so moving on to the previous page. Here I have discussed that why we're doing integration, and moving on to the page again, why we are taking the property 1 of PDF is property 1 of PDF is non-negativity. Non-negativity because this is an area, and if a function will be a negative one, the area will be negative, which is never possible. So you must remember this one. Okay, remember, must remember that property 1 is property 1 is that the function must be non-negative function. This is your property 1. Okay, so as you know now, then the random variable is continuous if and only if there is a non-negative function such that um, this is the situation. That is, you will integrate this from you will integrate this from a to b. Sorry, that area, that, and derive this one. If you are required of finding the um, probability in that point, you need to just integrate the area and we have to b, that is the product. Okay, this is the thing. So the f of x here is the probability density function, the PDF of x. So if you read here, there is a thing written here that if there is a non-negative function f of x, and if you integrate that function, that is f of x with respect to dx, you will get the probability of x, and that is um, other first condition is it must be non-negative. Then we will have to integrate this one from that for that area. We will get the probability of x. This is the thing, and the small f of x is the probability density of the function. Now, I have already told you this thing that this ensures that when you calculate the probabilities, which are the areas under the curve, you will remember that it must be non-negative, which is impossible. Which the area will be negative, which is impossible. Okay. Earlier, have finding the area for the definite point, or if you are required of finding the area for the continuous thing, that is for uh, a thing of the uncountably infinite situation, we need to uh, integrate that from that point, so that it must be covering all the points for that function f of x dx. So if we think of some examples, we'll be writing that p of 1, that the x is in between, x is a point in between 1 and 2, and you need to find the probability of x. So you need to put the values, so integration from 1 to 2 f of x for that point. We find the value like that. 2 is a point in between, x is a point in between 2 and 3. You need to find the probability for that point in between the 2 and 3. Simply just need to integrate from 2 to 3 f of x. So here there will be a great example to make you understand more about this thing. Carefully listen this example so that you will remember everything. So for the insurance company does what? Insurance company does what? If you have taken a car insurance and if somebody somebody had an accident, God might not do it with anyone. So, but some if there is an accident, insurance company is want to the insurance company and you want to claim your insurance. Insurance company first checks whether you are traveling with the speed limit. This is the first condition to give you your insurance claim. Second condition is maybe you can think of it. There are many conditions. After that, they will be given to. So, if we Think of the first condition, that is whether the car is traveling at the speed limit or not. There will be mathematician or they have a higher calculate this whether the car is moved at required speed or not. So to calculate this thing, the uh, manager or the company owner will tell you that to the mathematician whether to check the car is moving at the certain speed or not. After that, they will be giving them the instant speed. So there is no speed recorder presented there. So there is a situation they have given a function uh, that is depending on that one. They have given a function. Suppose they have given a function that inputs the speed of the car here and gives the probability. So if you want to check the speed of the car, whether it is traveling between 30 to 40, and you go, I have told you how to calculate that one. So you need to integrate from 30 to 40 of that function f of x dx. Then you will get a value. Suppose you think of this value is 0.02. This value is very less. So you have calculated the speed from 70 to 80. You jumped a bit because this probability is very less. The uh, probability that of 40 to 50 or 50 to 60, if you find that will be also um, linearly 0.02 and it goes up to 0.1 or 2. Then you have calculated the probability of the speed between 70 and 80 kilometer per hour. You got a value of 0.5. Then you have some. Hmm, we'll be calculating that whether the speed is moving above the speed. I have calculated like 100, that is 110 f of x dx, and you got a value of 0.9. This is the highest probability that the car is moving at this speed. And your speed limit there is the road. The speed limit given is 80 km/h, and you are traveling in between the speed of 100 to 110. When you have calculated by putting the value in that function, you got the highest probability that is 0.9. The car is moving at 0.9 speed. Sorry, the car is moving at 100 and 110 speed because that have the highest probability. So the insurance company will simply cancel their insurance, no insurance, because their first criteria is already uh, means first criteria did not meet the conditions of that car is overspeeded car. So no insurance. Okay, this is a real life thing of continuous learning. I think I have remembered everything now. So moving on to the second property of the PDF. Um, here is the second property. The second property says that integration from minus infinity to infinity. So I'm writing it here. Integration from minus infinity to infinity of f of x dx is must be 1. Okay, this is the normalization property. When we will be learning the first type of continuous random variable, we will be learning more about this one. This is their property 2. You must remember it for now. remember something, then you will learn what is it, then you know it for remembering. What was remembering. So, moving on to the first basket. Here we have our first basket as uniform random. Okay, for uniform random variable, consider a random variable x that takes values in interval a and b. A and b, it is written in square bracket. You must be knowing that what is the meaning of the square bracket. That is the a and b are included in this one. If x is in value in between this one, then a and b must be included in this interval. This is very basic. So assuming there are two sub-intervals of the same length have the it must not have the same length, but it must be falling in between them and same length of the sub-interval. Okay, means if you are thinking of the numbers between suppose you have 5, 10, 20, sorry, huh, and then 30, and you have numbers in between the fours, you have numbers 5, 10, 15, 20. Okay, and your interval is in between 0 and 30. Suppose, sorry, 0 and 40 as you have we have taken in this one, in this 35, 0 and 40. Suppose the subinterval, as we were thinking, the subintervals are suppose 5 and 10, 10 and 5, 15, and 15 and 20. The subintervals must have the same length as here. It has the same length 5, 5, 5. But in this case, the interval of 5 length, 10 and 15, so this cannot be a subinterval. Subinterval must have the same length and have the same probability. So, firstly, we will assume that what the condition was taken, we'll check and prove the property. Then we will guarantee that this is the formula for the first step, that is uniform random. So, we think of an interval and x is in between that interval, then it is saying that f of x, f of x is f of x is 1 minus a. We will now prove this thing. We will be more clearer about this. So, if you have typical case of usually what we do, we take the intervals as the first, the lower one, lower limit is as smaller, and this have the upper values. Usually we do this. No. So this is a. The pencil is disturbing me a lot. So wait from a few minutes. Here the non-negative property says that if 5 is A and 10 is the B, then uh, uh, we must have assumed that the B is greater than A. So if uh, B, this is, sorry, I have written wrongly. This is A and this is B, and B must be always greater than A. So if b is greater than a, then 1 by b minus a will be positive. If this is positive, the function f of x will always be positive. This is what we need to prove for the first property proved. First property proved that it must be non-negative, that b is greater than a, then 1 by b minus a will must be have the positive value. Have the positive value. Now we are checking the property 2 for the PDF. So property 2 states that if we are doing integration from minus infinity to infinity of the function f of x dx, then we will get the value of the property will be 1. This is the normalization property. This property proves that this is a PDF experiment. So now this property we prove from minus infinity to infinity f of x dx, that will give us that I have proved that the property is uh, limit value from a to b, and that property is defined, and otherwise the value will be 0. So minus infinity to a, if we calculate that function dx, plus from a to b, that will calculate, and from b to infinity of f dx, we are getting this value as 0 and this value as also 0. H, the limit is defined only in between a and b, and otherwise this will be 0. So we remained with uh, a and b, that is 1 by b minus a dx. So we are getting 1 by b minus a. This value gives us 1, hence proved. This property proved. This is a true property for uniform random variable. So now I am giving you one example to have more clearer vision about that thing. So you need to do this question. What happened? So you need to do this question. Now itself. I am pausing for 2 minutes. Then I will say the answer. So your countdown starts. Sorry. Before that, I make you understand the what question wants you to find out. So you have a number in between x and x, that is that have interval from 0 to 10. So if you calculate that from the interval, you need to find the probability of this thing. Probability of, so the answer is also given here. Probability of 5. You need to find this probability of that subinterval. So continue. So I think you have done. If you have not done yet, you must pause the video and try it by yourself and again continue. So if we draw this one in a number line like this and we will calculate, it will be more easier for us. So if you are, if you can see, there are 10 sub-intervals between the numbers from 1, 0 and 10. That is the interval given here. There are 10 sub-intervals and you need to find the probability in between um, 5 and 6. So you need to integrate. As you can see easily that the probability must be 1 by 10. But you need to prove that thing also. How this will happen. So for that you have integrated the value of f of x, that is interval 1 by integration from 1 by b minus a from uh, 1 by b minus a dx from that interval. Some intervals you have taken, some intervals are here 5 and 6. So you must integrate that value to get the answer. Are you clear now? Everything clear? I'm not thinking anyone having any queries in this. So your next question is this one. You need to find the probability in between 7 and 10. So uh, you have 7 to 10. So you will be calculating from 1 by 10 minus 0. That will be your value. Then it will be like this. Force and try, then see my answer. So it will be like this. Integration of x dx, and this value came out. So here there is no x. It will be from 7 to 10. So 1 by 10, that is 10 minus 7 by 10. This is your answer. So f of x not changed for any value. F of x is fixed. The interval, this one, the value of this one is fixed for a interval. It must include for a interval. Okay. So moving on to the next topic, we have our next topic is a PDF can take an arbitrary large value. So we will now discuss this one. PDF can take arbitrary large value. So let f of x is a random variable with PDF. F of x is 1 by 2 root x, 1 by 2 root x, and define that f of x is the interval from 0 to 1. Otherwise, this will be 0. Okay. To draw this graph for every situation so we are doing, you will have more better deep understand about that. Here, suppose this is the point 1 by 2 root x. This is the log for f of x. This is for x. So the function is proved for this point, proved for this point. Otherwise, it is 0. Here also it is 0. For this point, this is proved out for this. Okay. For this condition also, this is not the another basket. This is only the thing that the probability, the PDF large value. So let x be a random variable with probability with PDF, and f of x having the function 1 by 2 root x, that is defined from 0 to x. For this, you need to understand this thing first. Okay, so for understanding these things, you need to put the value and check. First, put f of x. This is saying the thing that if you are tending the value to 0 plus just above 0, means that is, you can say we're tending to 0. Okay, so if it tends to 0, the value of f of x increases. You can take examples like put the value this one, check, then put the value this one, check, put the value, put the value, and then put that value, put the past value first. I think you have checked for the first condition. Now check with the second. You will be getting some value of f of x. Here, when you are putting these values in f of x, you are getting some values that this value must be, if you draw the graphs for these three values, the value of f of x is increasing like as we are moving to x. Wait, as the x tends to, here you can say, as the x tends to 0, the value of f of x is increasing. So this is the thing. Of x, then x is increasing. F of x is not necessarily to be less than 1. This thing you must remember. F of x not necessarily must be less than 1. Can take a value, can take a value much greater than 1. But the integration of f of x dx must be 1, as this thing is showing the probability. Okay, so this is the thing. F of x must be less than, uh, um, must not be greater than 1. Okay, and this is the probability. This can take an infinitely large value. So f of x must not be negative. Must not be negative here. You think of negative numbers, there will be an imaginary value come as this is root over of x. There will be an imaginary number. We don't want to create that type of clumsy here. So we must not take x value as 1. So the function must not be non-negative. First property proof. The second thing is the normalization property. That is minus infinity absolute f of x. Um, our putting this value and this is defined from 0 to 1. So put in the value. So you integrate this one 1 by 2 can outside. So x 1 by 2 is increased by 1. It is increased by these things must not be done by you must do it by yourself. Must pause the video and do it by yourself. As I engineer have learned in your 12 to text dx, you need to prove this as 1. So Ls is equal to 1 by 2 taken out, x minus 1 by 2 plus 1 minus 1 by 2 plus 1 from 0 to 1. So 1 by 2, x is 1 by 2 is 1 by 2. So the value is 1 by 2, 1 minus 0. This value 1 by 2 can we have no must check it. Teach it down, plumb to the well. Okay, now the expectation of the continuous random variable is defined as the integration from as the expectation of that discrete random variable. We do sum of x, that is the PDF p of x dx, like this. In case of continuous random variable, I have to integrate from minus infinity to infinity. So x f of x dx. So then we will read this page. This page says that this page proves all the properties of the discrete random variable. What I have done here. This property says that if x is a random variable and we have taken the function of x, that is there is function of x g of x that must be the with the random variable. Suppose you can set up like this. But doing it here. To take x as random variable as then g of x, or suppose f of x will be random variable. So here what it wants to convert. So if f of x is a random variable, so there you are doing the sum of the expectation of g of x is sorry f of x is sum of f of x pmf of x dx. This thing we were doing here also the same thing. From minus infinity to infinity, g of x 1 by that is the PDF of with respect to dx. So you have put in suppose you need to find the variance thing. So g of x is a function of x, that is suppose x square. So expectation of x square will be integration from minus infinity to infinity probability x square p of x dx. Sorry, here the figure f of x dx. Okay, so when you will get the value, you need to do the thing. The variance is nothing but the same where false expectation of x square minus expectation of x whole square. So variance can also be written as, if you can remember, this is the second proof we have done. The first proof is expectation of x minus expectation of, this is in terms of our statistics. Okay, if you can remember this thing, this square width, writing it again. Expectation is x minus expectation of x whole square. If you are remembering the thing that for statistics that you are doing, you can remember everything. So sigma equal to integration from, sorry, introduce integration and strategy of x side, x side minus x bar x side. Here this thing is not happening, if you can remember, and this is the mean, and this we have proved this one. So variance of x from minus infinity to infinity will be x minus this one, as this one is also as removing this thing as this thing x minus expectation of x whole square is an um, this is a function of g of x, and I will be doing g of x and PDF of PDF of. So the probability is nothing but integration of x and the function of x and the PDF of x takes from minus infinity to infinity. This is the variance of x, and for the expectation you need to integrate from minus infinity, that is x f of x dx. This is expectation of x, expectation of x. We have done here g of x because we need to find the x square thing, but here we don't record of x square thing, here the x is enough. So now we will prove the mean and variance of uniform random variable. So let x is an uniform random variable. So I have proved this one, that how this is true, and this is part. So this is proved from the two properties. Property 1, I have proved this much. I am revising now. Okay, you can revise with me. Property 1 is non-negativity. Non-negativity. Non-negativity says that b is greater than a. So 1 will be minus a is greater than a. So must be non-negative. So the value is always giving is positive. Otherwise, this value is 0. So property 2. Property 2 proves that. Property 2 proves that it must accept the normalization rule. Normalization proves that integration from minus infinity to infinity f of x is giving 1. So integration from here, extended this integration from a to b f of x gives the value 1. otherwise this is 0. So put this one and now zero. So expectation will be simply x multiplied by 1 by b minus a. So have done the expectation. This is the thing. Okay, must pause. Do pause here. Here you need to pause. Okay, pause here. Try, then continue. Watch. So if I can extend this one, 1 by b minus a, b minus a, b plus a by 2 cancelled, b plus a by 2. This is the formula for expression for 2 now. Okay, I think everyone is clear how this properties work. Remember in the way b plus a by 2 because it will help you learn the variance part also. So now moving on to the variance. For variance, we need to find expectation of x square. We have done this one now. So integration from minus infinity to infinity, x square f of x dx. So I have put here the value of g of x, then the PDF of x. It gives 1 by b minus a is constant taken out. It continues x cubed by 3 from a to b. So 1 by b minus a, b cubed by 3 minus a cubed by 3. So if I'm remembering the property, so it is given 1 by b minus a, b square plus ab plus a square by b minus a, and the remaining 3. So cancel this one, b square plus ab plus b square by 3. This is the value of expectation of x square. So put the value of expectation on the formula expectation of x square minus here expectation of bracketed whole square. So we are getting this thing, and now this the next part and do it by yourself. So as b is greater than a, we are getting a variance of b minus a whole square by 2, and the expectation here is b plus a by 2. Here variance is b minus a whole square by 12. So pause a bit here, take a break, then we will move on to our next basket, that is exponential random variable. You need to have some energy for that. So I think you all are back. So what I have discussed, the expectation is b plus a by 2, and the variance is b minus a whole square by 12. This is for uniform random variable. Okay, now moving on to the next basket, it is exponential random variable. Okay, exponential random variable states that an exponential random variable has an integer of X lambda is to the power minus lambda x. This is our expectation. X is defined from lambda to the power minus lambda x. So x must be greater than 0. This is the thing we must remember. Otherwise, it is 0. So now we'll prove the two properties. First property is the non-negative property, and the second property is normalization property. You need to pause the video here and prove it by yourself, then continue. So non-negative property here proved by itself that the thing is lambda must not be non-negative. So when lambda will be non-negative, that it must not come. And the lambda is always positive. So then e to the power x. This also gives a constant value. This also constant. So the product value of f of x is positive. This proves our first property. First property proved, that is non-negative. No, first property of non-negativity proved. No. Moving on to the next property, that is the normalization property. Normalization property states that if you integrate from minus infinity to infinity of f of x dx and put the value minus infinity to infinity, that is to infinity lambda e to the power minus lambda x, then lambda is taken out, then we have e to the power minus lambda x. Then if you remember, this is from minus infinity to infinity, but uh, the value is given only from 0 to infinity. From 0 to infinity power and the uh, lambda equal to minus of e to the power minus lambda infinity minus e to the power minus 0. So the value e to the power minus infinity, e to the power infinity is 0, but e to the power 0 value is always 1. So minus of 0 minus 1 gives 1. Hence property 2 also true. If we were stuck that whether lambda value is always be 1, so if you remember the thing in the Poisson random variable, then you must have known that lambda is nothing but the uh, value that is the number of events that happen for that interval. So lambda value must not be entered here. I'm giving you an example. Lambda is, if you can remember, a website gets an average of lambda equal to 5 visitors per minute. This gives the inject value of 5, that is lambda must be mm, 5. If the visitors must not be less than 0. So here the lambda value must not be negative, cannot be negative. uh, you can say. So this is our second aspect. So now define for the negative values of x. Random variable always measures quantity time. You can bring that time path ID through वहाँ पे exponential random variable करेंगे. Okay. So the examples when we use the exponential random variable is when we are talking about the time until an incident of interest takes place. Suppose breaking down of some equipment or burning out of light bulb or an incident occurring. These all are example of exponential random variable. So the end of something, the interest of that incident of interest taking place. How this is different from the Poisson random variable, I will discuss it now itself. So talking about scenario 1, and you can think of, suppose we are interested in uh, uploading job कब when we will be getting a job. It can be you can get a job in 2 to 3 years, in 2 years, or 2 years, 2 months. It can be so. The first scenario talks about the incident of interest taking place. Next is the difference between the Poisson and exponential variable. Suppose we have an LED bulb. So the Poisson questions that एक साल में कितनी बल्ब खराब हो जाएगी. डेफिनेट टाइम इंटरवल में काम लिया जाता है पॉइसन रैंडम वेरिएबल. पर एक्सपोनेंशियल रैंडम वेरिएबल एक एलईडी बल्ब कितने टाइम तक चलेगी मीन्स एन इंसिडेंट ऑफ इंटरेस्ट of interest. Here, the person involved, the person involved uh, to assume the incident according to his or her interest. But here in poison, there is no involvement of person to assume the incident. It occurs in definite time interval, like the number of customers coming to a shop uh, for in a time interval, suppose 7 to 8 p.m. Where no person is there to assume uh, the incident according to his or her interest. Okay, there you will use the exponential random variable. Okay, taking another example. So here the incident of interest is we want to check. Uh, we are hired by a company and we want to check and give the warranty of some TV, and we want to sell the TV uh, divided of the other two companies. So there is a character documentation from Chota Bheem. Okay, so here we will check that what is the probability that the working of the TV will be means incident of interest is TV का खराब incident of interest is TV का खराब होगी. Okay, incident of interest is TV का खराब होगी. So they checked first to check from 0 to 3 years and find the probability that 0.8 is the probability that TV will not have any problem in between 0 to 3 years. It is very high, so they will be checking for the next. That is 0 to 4, 0 years to 4 years. That the TV will not give any problem from 0 to 4 years. They also get a probability very high, that is near to 0.8. So they will again check for 5 years, then for 6 years. The probability is 0.5 or less than that. Then they will give the warranty accordingly, so that their TV must be sold a great in a greater value, so that others TV must not be sold by the other companies. Okay, so here, based on this warranty itself, the TV companies give their warranty. There are many TV companies like Sony, Samsung, Mangelson's company also has the same approach, that there is the same functions that is uh, provided in the TV, but different is what value differs from the company to company. That is the value of lambda is not same. It is different. Lambda value changes from company to company. Lambda always vary from company to company. Lambda depending on all these metrics: marketing, material, R&D, process, research, everything. Everything depends on the lambda value. Accordingly, they will calculate the function of x, they will integrate the value of e lambda is equal to minus lambda x dx. Accordingly, this is the real life use case of exponential random variable. When exponential random variable when it continues, and if x is an exponential random variable, we want to calculate that एक साल से ज़्यादा चलने की प्रोबेबिलिटी क्या है और 3 साल से ज़्यादा चलने की प्रोबेबिलिटी क्या है. we need to calculate a value that must work, that x must work from a certain value is from certain value. So the thing must work. The TV will work here greater than a year. There will be no problem for 1 year. Greater than 3, greater than 4, greater than 5. So we will put the value from now we will not do from 0 to infinity because from 0 we have change the value. Here from 0 to a value of f of x 0 we have defined from in value. It will work from a to infinity f of x dx. So putting the value like this, then solving it. Lambda taken out, this also taken out, lambda a value 0, this value 0, this value gives e to the power minus lambda. Probability that x is greater than or equal to a e to the power minus minus lambda a. So, e to the power minus lambda a. E to the power minus lambda a. You must remember the things, formulas that if think of probability of something works greater than 0 is the formula from 0 to infinity. You will integrate that one lambda square minus lambda a dx, and we will assume that it will work from greater e to the power minus lambda a, which is equal. Now we will prove the mean and variance of x. So mean and variance of x. So for that thing we need to do a plane space here. Suppose, wait a minute, captures all the things just told you to now. is the thing. For expectation, we need to do from extra. So this can be written as this lambda taken out. Here you need to put the by parts and solve. This is one and this is the second. Highlight exponential will be in the end and the algebraic will be in the first. So you need to put the values that you will be getting. The value of the expectation is expectation from the lambda. I can prove this one, but I need you to, and the explanation is also given. Okay. So for expectation of x square, also given here, the vector to find the variance. So this is also calculated in the form of by parts. By parts is done. We got an value. So the variance is e of x square minus expectation of x whole square. So we got the value of this one as 1 by lambda square whole taken. So the value of expectation square is 1 by lambda square and the value of this comes to 8 is 1 by lambda square. Variance is 1 by lambda square and the expectation is 1 by lambda. This is the thing. So I have a question now. This is your question. You need to solve, and after that we will be proceeding to cumulative distribution function CDF. I think we will pause this video here and take up the cumulative distribution function in the next video. So now I will tell you the answer. You want me to pause a bit now? Again, as the pencil is not working, forgetting to charge. We will continue up from the CDF in the next video. Continue the CDF and complete the CDF. talking about now. The expectation is get here is 10 days next days. So expectation as exponents when variable is when the lambda 10. So the lambda value is 0.1. And here you need to find uh, a level of the thing that is the meteorite between 6 a.m. to 6 p.m. So we need to find those two things in days per month. So on the fourth day is the sixth, think of the 12-hour clock. 0, 6, 12, 6, 18. 12-hour clock. It's in fourth of the day, and 6 p.m. equal to the 18 is the 3/4 of the day. Okay, 3/4 of the day. So we need to find the probability that the incident of the uh, incident of the interest takes place in the okay. And that that dinner already both come up. So I can check this is the answer. It's from Exponential first. Next is cumulative distribution function. So the cumulative distribution function is given that when you compare when to use the PNF and when to use the CDF, PDF. So use this thing. Similar the method and the two is like this and the other thing is separate. Okay. The figure of it x is limited to x provides all the values x is less than taking all the that all the values that so that thing what will this x is equal to x with in the previous, but here let x is less than equal to means taking all the values up to that point. Let's see the example. We will have better deeper understanding what exponential can be. So x is in discrete random variable, and x is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we want to find that the CDF of x. So yeah, we will be doing p of x x less than equal to 5. So we need to sum all the values to 5 as this is given equal. Then you can represent this as sum of k, that is less than equal to 5 p of x k, and if we need to find this thing to the CDF, we need to integrate after that. Okay, so taking an example of the integration 2 with one that we will be discussing that also. So let us choose in display a kind of variable array 1, 2, 3, 4. So the fourth probability of x is 1, probability of equal to 2 is 3 by 7, equal to 3 is 1 by 7, is equal to 4 is 1 by 7. So is it okay? 1 by 7 plus 3 by 7 plus 1 by 7 plus 1 by 7, 7 by 7, that is 1. So as the PMF is all the values of x is greater than 0 and the PMF is 1. So let's prove that x is. So if you arrange this thing, arrange this thing, arrange this thing 1 by 7, 2 by 7, and 3 by 7. Discrete is 4 plus the sweet point. So if x equal to 1, x equal to 2, equal to 2, it is this one, 3 this one, 4 this one, this one, and that is 3 for suited test, we need to take all the values, including I will say the graph aside this why I need to draw it. So here you can see that for point this one, what that one is still there, f equals to 1. That is f of x 1. That is p of x less than equal to 1. Less than or equal to 1 will be all the values in the previous. if there is no value, 2 by 7. This will take the value 2 by 7 only because the value of uh, the value of what? Value of x equal to 1 is 2 by 7. So if you take equal to 2, then you need to do is 2, you need to do P is equal to 1 plus P is equal to 2. So the first 2xn plus 2xn, that is solution. We need to take the P of x plus 3 and also label 4. Then the CDF of the given random variable is written like this. 0, 0 is value ranging from 0 to the minimum and 7.23. So as 7 from a value, but for a student 1, the value is greater than 4. Now we need to prove that if x is an continuous random variable, will be this 1 by the minus 2. Okay, we need to find. So thank you for this video.